Hey everyone, I'm Itzik Ben-Gan. I'm with Lucient. Welcome to the virtual PAS Summit 2020. I'm really glad that PAS managed to pull this conference off despite all of the challenges. I hope very much that in the next year event we will be able to all meet physically. I really miss being able to meet people, travel around the world and seeing places. But it's really great to still be able to conduct the event under the circumstances. So the topic for this session is looking at all kinds of workarounds for missing T-SQL capabilities, either some functionality like features that are not available or certain restrictions in the product. And by the way, some of them are there for a very good reason. So even though people try to get around them, I just explain why in some cases it's just not a good idea. If you want to download the source code for the session, just visit my website, tsql.lucient.com. You will find there a section with resources, and within it, download for recent conferences, including the sample databases that I will use during the session. So PAS has many different activities to offer, even in this virtual capacity. So make sure you check out the different available activities. You can check out the website pas.org for more information. As for your feedback, as always, after the session, you will have an opportunity to provide your feedback. It means a great deal to us. We learn quite a lot from those evaluations. So please make sure to take the time to fill those out. And obviously, there are lots of great prizes involved as well. As for myself, as mentioned, my name is Itzik Ben-Gan. What I do most of the time, let's say in normal times, is travel around the world, meeting customers, primarily teaching about T-SQL. I do a lot of writing about T-SQL as well. These times, I do pretty much the same thing, but primarily in an online capacity. So I mainly teach T-SQL related classes, query tuning, those kinds of topics. In fact, I hope that you will like the material that you will hear about in this session so much that you will want to attend one of my longer, extensive 5-day classes covering various advanced SQL topics. You can find more details in my website, tsql.lucient.com. If you want to get in touch through LinkedIn or Twitter, you have my details here. I'll be more than glad to connect through those channels. As for the agenda, so we're going to go over the following items, basically starting with features that you would normally like to see in T-SQL as T-SQL elements or language elements, but you don't have those and you need to come up with your own workarounds or your own customized solutions. We'll start with computing the minimum or maximum over columns. You obviously have basic elements in the language to be able to compute aggregates across rows, but when it comes to columns, things that you can do in spreadsheets like Excel and such very easily, apparently it's not that straightforward to do in T-SQL, so I'll show workarounds. Computing row numbers. Often we need to compute row numbers as well as other ranking functions based on some defined order. However, occasionally, even though not in the majority of the cases, but occasionally, you just need to compute those row numbers with no specific order. And apparently, it's not so straightforward. So you need to come up with your own workarounds, and I'll provide some recommendations. Then a request that I've got so often, and I've seen many people attempting to achieve, but one of those things that are limited in the language for a reason. So we will look at the typical requests that people have to create sorted views so that their users can query those views and get the data always ordered without the need to add an order by clause in the outer query. So I'll talk about why the language and the underlying model actually reject this kind of idea, but still what kind of attempts people make and why they're not such a good idea. And finally, we will conclude with a missing capability, not specifically in T-SQL, but generally in SQL, the standard language. When you define column aliases, say in the query select clause, and you attempt to use them in clauses like the where, group by, having, and so on, this is something that the language doesn't support. So here I'll explain why it doesn't support this option. There's a very good reason for this limitation, but then we will have a look at workarounds for this. So let's go ahead and get started. Most of our time we will spend in SQL Server Management Studio. A couple of sample databases that I will regularly use during this session. T-SQL v5, very, very similar to the Northwind sample database that you probably had a chance to work with in the past. Even though Northwind is not supported currently in SQL Server, I really, really like it to demonstrate conceptual aspects of T-SQL code. So I created my own sample database originally based on Northwind. It has a kind of a simple order entry system. And then another one called Performance v5, simply having larger tables. And I usually like to use this database when showing all kinds of performance related examples where I need some more substantial amounts of data. So you have links to download these sample databases from the source code for this session, but also you can just go ahead and visit tsql.lucien.com, and again, under resources downloads, you will find also downloads for these sample databases. So let's go ahead and get started. So our first item on the agenda is computing the minimum maximum over columns. For this, I'll use the following sample table called sales. Let's go ahead in an empty area and have a look at it. This will be in our T-SQL v5 sample database. So here's the table that we will use as our sample data. As you can see, we have a row per customer, we have a column per year and quantity, and our goal is to apply aggregates across those columns. Let's say pulling the minimum or maximum or both. And here we have only 3 columns, and I am guessing you're thinking, well, this is something that I should be able to do using a function. And indeed, you will find that some platforms actually support functions called greatest and least. So it should be as simple as saying greatest and then passing those columns in question, quantity 2018 and then quantity 2020 or 2019, and then producing our max QTY, and similarly a function called least that would produce the minimum of those, right? So it's so natural to expect to be able, those things are after all a common need, but at least T-SQL currently doesn't have support for such built-in functions. And certainly if you migrate from other platforms like Oracle who do support this, it's certainly something that you want to be able to achieve, to be able to migrate this code into SQL. So what would be the workarounds? I'm guessing that many of you are thinking, well, I should probably be able to easily achieve this using case expressions. Well, you know, a case expression probably could work if you had 2 input elements doing a simple case. When one side is less than the other, produce the first side, otherwise produce second side. But then what if we have 3 elements? And you're probably thinking, okay, I'll use a table expression and apply similar logic between the outcome of the previous case and the third element. But now imagine if you had 50 elements. So even with a bunch of table expressions, after all of the unpacking of the logic, you will have kind of a monster expression. So definitely not a very good idea. So an alternative is actually to use techniques that are quite similar to unpivoting capabilities, even though you don't necessarily want to use the unpivot operator because technically it limits you to unpivoting only one measure. And perhaps we want to do it with multiple measures. Here we have 3 quantities. What if we have 3 quantities, 3 values, you know, and so on. So using a different solution that utilizes the apply operator, this is actually quite doable without a very high level of complexity, and actually also in quite an efficient manner. So let's see how this is done. So first and foremost, what we will do is we will go ahead and sort of unpivot the multiple columns into multiple rows, holding a single measure, which in this particular example would be the quantity measure. So we will go ahead, let's say we name this sales table S, and then apply, cross apply. And then here we'll create a table expression that we'll name, let's say, A. And within it, we'll go ahead and unpivot the columns into rows. The way we'll achieve it is we'll use a query that will apply the aggregate computations. Let's say that after the unpivoting, we will create a column that we'll call QTY. Then we'll apply both the min QTY and the max QTY against this one column that we'll name QTY. So max QTY. So all of this will be issued against, and now here's the trick that we'll do our unpivoting. We will define a derived table, let's say we'll call it D, with a column called QTY, based on a row value constructor. So using the values clause, the one that you regularly use in insert statements, we can actually build a set of rows where each pair of parentheses represents a different row. So this would be one row, this would be a second row, this would be a third row, and so on. And each row will be made of an element that we will collect from the left row, from S, holding the quantity of the relevant year. So here we will have one column holding the quantity 2017, I remind you, from S, then another row made of the column with quantity 2018, and a third row made of the third column holding quantity 2019. The end result of what we're doing here is basically per left row, a set of 3 rows with one column holding the quantity from the relevant year, and we're naming this result column QTY. Then we have the outer piece against the table value constructor, actually collapsing those 3 rows back into a single row holding those aggregates, the min and max, which we call min QTY and max QTY. As for the outer query, well, here I'm using star. Normally we just list the individual columns, but basically we're now listing the 4 columns that we currently have in our input table sales, which we named S, and 2 target columns that were created by our table expression that we named A. So notice the outcome. As you can see, we have both the original 3 columns holding the 3 years, as well as the min QTY and max QTY. So it's a really cool technique that essentially applies unpivoting, but using this kind of custom, technique that relies on the apply tool. Very, very flexible, very, very handy. All right, we're moving on to our next workaround. So this is a need that I had quite a few times. I regularly use window functions, including ranking functions, and probably the most useful of those is row number. The thing is, a row number naturally in the vast majority of the cases needs to be computed based on some specific ordering. So let's take as an example maybe a computation against the larger database performance. Let's say I wanted to compute row numbers for rows from our orders table. So let's query the orders table. This table, by the way, has 1,000,000 rows. So let's say I'll pull order ID, and perhaps I want to compute a row number that is based on, say, date descending ordering. So order by order date descending, and maybe order ID descending as a tiebreaker. Right. Thing is, for this computation to get optimized well, we will very likely want a good supporting index in place. Yeah. So if we go ahead and check out the query plan for this query, as you can see, SQL Server recognizes that there is a supporting index created on order date and order ID. And therefore, it is able to rely on its ordering to provide the row number computation with the data in the order that it needs. So notice that the ordering property says ordered true. When we scan the index, the scan operator is requested to deliver the rows based on index order. We can even look a bit more closely. If we look at the properties of the scanning, we will see that the scan direction is backwards. So maybe it's a little bit hard for you to see because my face is actually hiding this, but you can see here that the ordering property says that it's going in a backward direction, right? So we can go either forward in the linked list, we can go backwards in the linked list, both can work. And then the segment operator getting the rows ordered by the window partition element if there is a partition by clause, or if there isn't, we're just assuming that everything is one big partition. A segment just flags the sequence project operator when a new partition starts. And then sequence project knows at the beginning of the partition to set the value to 1, otherwise to just add a 1. So the point being, we avoided a sort activity in this plan. What's so important in avoiding a sort activity? Well, for one, there's the scaling. Once there's sorting, the scaling, instead of being linear, becomes n log n, because we have n times log n comparisons in the sort activity. Plus the response time. When there's sorting, the entire input needs to be ingested before the first row can be delivered. So with sorting involved, if the input is very, very large, imagine you're querying a table that has many millions of rows, it could take some time until the first row is delivered. Whereas a plan that does a single pass over the data and no sorting, you realize it pulls a row from the input, it computes the row number, and immediately emits the row to the output. So it's both linear scaling and immediate response time when we have a supporting index. Thing is, if we don't have the right index in place, for instance, if I went ahead and ordered by something that I don't have an index on, let's say employee ID and order ID as a tiebreaker, you will see here when we examine the query plan that there is a sort operation involved, and as mentioned, the scaling, the dominant part of the plan clearly is the sort activity. The scaling becomes n times log n, and the response time is naturally affected. So either way, when we need the data ordered, the best thing we can do is just make sure that we provide, when we need the data processed ordered by the window function, of course, we just need to make sure that we have the right index if we have the option to create it. But how about those cases where perhaps you just need to compute unique row numbers and you don't really care about ordering? So think about this. Did it ever happen to you that you just needed to compute unique values and you didn't care in what order to assign those? So I had this need quite a lot of times. Again, the vast majority of the cases I did need those ranking functions ordered, but occasionally, enough times I needed to compute those row numbers in no specific order. And then there's the question, how do we do this? Well, the very first attempt is naturally to say, well, how about if we just don't put an order by? You would think that the language should allow this because anyway it allows us to order by something that is not total ordering, by something that is non-deterministic. Like I could say order by, say order date, even though the order date alone doesn't give us total ordering, right? So we could have multiple rows with the same date. So it's kind of, I would say, arbitrary or strange that on one hand, the ordering doesn't have to be deterministic, but on the other hand, there must be a window order clause when you use ranking functions. So try not to indicate ordering, and you will see an arrow saying, well, there must be an order by clause involved. Now, just recently when I was teaching, one of the students asked me, well, can't you just say order by whatever is, say, the clustered index key? So for instance, here our clustered index happens to be based on order date in this table. Can I not just say order by order date? If I don't care about order, any order is fine. Well, you would be right, but then again, think about this. For one, once you specify ordering, even if there is a supporting index, you're limiting the optimizer to basically processing the data from the index in index key order. You realize this. So it must, when it says to the storage engine, give me the data ordered by the index key, the storage engine is now more limited to choosing only a technique that delivers the rows ordered by the index key. So this would be a physical index order scan, not being able to consider even an allocation order scan that utilizes IM pages and scans the data in file order. Yeah. So, Oh, actually, how about if I use the correct syntax here? So this would be row number and then over, and order by, of course, goes here. So yeah, so I'm sure many of you are fixing my syntax as I speak, but that's good of you if you notice this. So now, if I have an index in place, I'm forcing the optimizer to use an order through kind of scan, and then the storage engine to apply an index order scan and not consider an allocation order scan. And worse, if I don't have a good index in place, we're basically forcing it to sort with the scaling related penalties and the response time related penalties. Here we can see that there is another situation. My clustered index is indeed defined based on order date as the key, but normally this particular query asking only for order ID and the row number perhaps has a much more narrow index than the clustered index with its full data rows that has only the order ID column within it. And now this index has the right data, but it doesn't have it in the right order. So now we're kind of forcing the optimizer to make a choice that is not really ideal. Either choose the non-clustered index that is narrower but doesn't have the data in the right order, so forcing a sort, or choose the clustered index that has the data pre-ordered and avoiding a sort. So we can check the query plan. And as you can see, the optimizer says, you know what, I found an index that happens to have within it, let's see which columns. Actually, it's not even the clustered index, it's a non-clustered one, but it has order date, it has order ID, it has customer ID, it has employee ID. It has a bunch of columns that are completely non-interesting for this specific query. It didn't choose to use the much smaller index that is defined on order ID alone. Okay, so anyway you look at it, basically we're forcing the optimizer to choose a plan that is not really ideal. So I'm sure many of you, when you needed to compute row numbers that are not based on any specific ordering, you wanted to find a technique that allows the optimizer to know that ordering is irrelevant, even if we must indicate an order by close. So I remember the first time that I tried to do this, my initial attempt was to try to put a constant here. Because you know that in many cases, when you're using an expression that has the same result value across all rows, and then you're doing some manipulation like ordering by, often the optimizer realizes that it's the same value for all rows and avoids the actual need to process the data ordered and then either use an index or force a sort. So here, what would be the attempt? Let's say if we try to use a constant like a number, let's say 1. Let's give it a try. So here, I'm trying to run it, and then you can see the optimizer, it's not optimizer, SQL Server says we do not support integer indices as order by close expressions. And essentially what it thinks that we're trying to do here is order by, like when you can put in a presentation order by close, order by the first expression in the select clause, which clearly is not what we're trying to do here. You could try something else, like maybe a character string. Yeah, let's say order by just a constant character string. Try again. And as you can see, it says window functions do not support constants as the order by close. So apparently it cannot be a number because it thinks it's an index, but it cannot be even any other constant because it just won't allow constants in general. So what it's really looking for is some kind of an expression as opposed to just a straight constant. It thinks that we would be using some column as part of the expression, but it just has a requirement to use an expression. So, you could try maybe something like this, writing an expression that results in the same value for all rows, thinking that this should resolve the issue. Well, let's give it a try and see what happens. And as you can see, it's still complaining about using an integer index. This looks a little bit strange. However, if you're familiar with the query processing phases, at a very, very early stage of the query processing before full-blown optimization starts, there's a phase where SQL Server applies what's called constant folding. It folds expressions that results in constants, what simplifies then the optimization process working with direct constants and not needing to evaluate those expressions. So this internally actually gets converted into the constant 2 as part of the constant folding phase. And now full-blown optimization starts. So now, as we know, we have this error message that indicates that we cannot use an index here as if we are ordering by the second expression. And the same thing would happen if you try this. If you try to concatenate two pieces, made of character strings, you would get the same error message as we got earlier saying, well, we don't support a constant because constant folding, first of all, converts it into this ABC constant. A very kind of odd thing, though, by the way, that actually apparently does work is there are certain things that will cause the constant folding phase to fail. And when the constant folding phase fails, it's not like the entire query fails. It's only that particular phase in the query processing that fails. So there could be things that simply will prevent constant folding. One example could be, a divide by zero error. So think about it. If this very, very early stage of query processing cannot apply constant folding because naturally it results in a divide by zero, we skip that phase. It's not like the query is necessarily invalid, by the way, because still the optimizer looks at this expression and says, well, this expression is made entirely of constants, so I know ahead that the outcome is going to be identical for all rows. Great, I don't need to order by anything, and it simply ignores whatever we put here. So notice how strange. First of all, if we try running it, it actually runs beautifully. Since there's no sorting or a requirement to pull the data pre-ordered from an index, then obviously the response time instantaneous. So even though we were processing a million rows, the first row was emitted immediately. If you will indeed look at the query plan, you will see this time we're pulling the data from the narrowest index that contains all of the columns that appear in the query. So the PK orders index is a non-clustered index that contains basically only order ID and the row locator. And what's also very important here is when we examine the ordering requirement of the scan, you will see the relational engine tells the storage engine, you give it back the data from the index, but you can do it in any order that you like. Now, letting the storage engine have more flexibility, basically, in choosing between an allocation order scan based on IAM pages or index order scan, and now decide based on a combination of consistency and performance kind of aspects, which of the methods to use. The point being, though, that we do provide the more flexibility, and clearly there will not be a need to sort in any case in this scenario. The other thing that I really, really like about this technique is that you can kind of personalize it. If you use constants, remember, if you say, this technique obviously is just an expression, but what if I wanted to pass some text because I wanted to kind of personalize my message? Remember, the original constant isn't really allowed, but then again, apparently there are other things that will prevent constant folding. For instance, if we pass a constant through a subquery, so if I say select, say a number, whatever is your favorite number, this fact that I'm using a subquery here prevents constant folding, and again, it sees it as an expression, and therefore it's a valid ordering specification for the window function. And as you can see, this will work. This will emit the rows instantly. If we check out the query plan, we will see the optimal index used, and the ordering property will be false. And as I started mentioning earlier, now that we can put any constant here, including a string, we can actually personalize messages. So if you're a geek and you want to pass messages to your friend, let's say I want to deliver some message to my wife, so I can always send information in this manner. We just had our 25th anniversary, by the way, just recently, so I'm sure she will like my query. So anyway, that's the technique that I like. There are a number of other options. The previous technique that I showed with the error, I don't really feel too comfortable with, I have to say. You never know if Microsoft will choose at a later point to change how they handle query processing and decide that they actually look for expressions that could result in errors. I don't feel too comfortable with this, even though currently it works. The technique with the subquery, I feel much, much more comfortable with. I usually actually like to use a null in my subquery just because it annoys a lot of people, the use of nulls. And in some cases, I really do find that they make a lot of sense to use. There's yet another option, by the way, that I also feel that is quite safe and quite all right, and that's using a runtime constant. So a function that gets evaluated only once at the beginning of the processing of the query, and then that value is used instead of the function. So for instance, if we take a function that returns the current session ID, so theoretically, whenever we run the query, a runtime constant could change. This particular one within the same session naturally won't change, but something like the current database ID, the current date and time, some of those functions naturally won't change between executions, even though theoretically someone else will invoke the function, it could change for it. But since the time, clearly, whenever we execute the query at the very, very beginning of the query execution, the runtime constant is evaluated, and that value is then used throughout the query. So it's still treated as a single value and serves the same purpose of the optimizer knows it's the same value for all rows, and therefore it doesn't really need to sort. So I've seen people like Paul White, my friend, often I've seen him using the session ID as a runtime constant, but anything that gets evaluated only once for the query technically could be a good choice here. So here, if we go back to the query plan, again, we will see technically the query is valid, and you can see the optimal index being used and the ordered false property, allowing the storage engine more flexibility in choosing the underlying strategy. So to summarize, I would say whenever you need row numbers that are based on specific order, obviously you have to specify that order. This goes without saying. But in those cases where you need just unique numbers and you don't care about ordering, because an order by clause is mandatory in the window function, just make sure that you use one of the techniques that, as I suggested, I see as safer. I would avoid, even though it's kind of curious, from an academic curiosity perspective, how the divide by zero error and other errors like overflow and such normally should fail, but in this case make it work. It's kind of just curious, but I would not feel very comfortable with it and suggest using either the subquery method or the runtime constant. All right, moving on to our next item. So creating a ordered view. So what's the story here? Well, first of all, I want to stress that a view in SQL, let's not talk about T-SQL, the dialect specifically, but SQL in general. A view in SQL is a table. And it might sound a little bit strange, but SQL's main structure that we're interacting with, the input to our queries, the output from our query, is supposed to be conceptually a table. And a table is SQL's counterpart to relational theory's relation. And in relational theory, all of our operations that do data manipulation interact with relations as their inputs. And the way we refer to those operations on relations is relational expressions. And a relational expression, just like an integer expression, operates on some inputs. In the relational expressions case, these are relations, and they emit a relation as output. And this gives us what relational theory calls the closure property, that the outcome of a relational expression is a relation, and therefore we can nest those relational expressions. And the counterpart in our SQL world is tables. A table is the counterpart to a relation in relational theory, even though there are many aspects in which tables sort of deviate from relational theory, but that's kind of a topic for a different discussion. What's important is that when we write a query, we're normally writing a table expression, right? We are interacting with tables as inputs, we emit conceptually a table as output, and we can nest those. Then we can use a named table expression based on a query and then have an outer query interact with it. So a view in SQL is basically a named table expression. Yeah. Unlike, say, a derived table or a CT, it's a reusable named table expression. When we create it with a create view statement in the database, we're just creating a reusable table expression that anyone who got the right permissions can go and query whenever they like. But from the language and the models perspective, a query isn't supposed at least to care whether it's querying a base table that we created with a create table statement in the database, or a view that we created with a create view and defined using a query that interacts with some base tables, perhaps. Okay, so why is this so important? I often got this request, how can I create a sorted view in T-SQL? And part of the reason, by the way, that people are looking for such a construct is because some platforms do support it, even though it kind of contradicts in a fundamental way the SQL design and its underlying relational theory. So, imagine trying to create, if we go to our T-SQL v5 database, imagine trying to create a view, create view, my view, let's call it, based on a query that does a select of order ID, maybe the value from order values. Now, if we didn't have any ordering relevance, then, nothing too special. And let me just make sure I spell it correctly. So nothing too special about this query, and nothing too special about this view definition. This is what SQL considers a table expression, and our view is essentially a reusable named table expression that is based on this query, right? And now I can go ahead and interact with this view, using some outer query, right? So as you can see, everything looks fine in this case. However, if you ever tried introducing an order by to the inner query, what is normally, of course, perfectly valid to do, if I took this query outside of the view definition and just introduced an order by clause, perhaps I wanted to return the rows ordered by value descending. There's nothing really too special about this query, but from the language design perspective, and more important, the underlying relational theory, we do have kind of a deviation from the model, in the sense that relational theory, remember, uses this relation as its main structure. And a relation has these two pieces. It has a heading, which is a set of attributes, and it has a body, which is a set of tuples. The counterparts in SQL are the heading of a table would be a set of columns, and the body would be a set of rows. Thing is, a set in mathematical set theory has no order. One of the most fundamental properties of a set is that it's unordered. We think of a set as a whole, as a single unit, with all of its members coming to existence as if at the same point in time. Yeah. So I said that in relational algebra, relational expressions operate on relations and return a relation as a result, and the counterpart in SQL is a table expression. Thing is, for a table to be a good representative counterpart of a relation, it cannot have order. And indeed, at least in the body of a table, it's defined as being made of a set of rows, and as such, it doesn't have any specific order. And I know that many of you are thinking, but wait a minute, I have a clustered index defined on this column in this table. Surely the data is stored in a certain order, and when I will query it, I will get it back in some order. Well, you could be very familiar with the mechanics of the database platform that you're using and its engine and how it stores data, and have educated guesses based on your knowledge of how the engine works and which strategies it has access to, of what's likely to happen when you will query a table, what's likely going to be the index used, and in what manner the storage engine will access its data. But from the conceptual design of the language and its underlying model, what you're dealing with is a set. And as such, unless you introduce an explicit element in the language that says, I want to get the data back ordered, the designers of the various database platforms know very well they don't have to guarantee that the data will be returned in a specific order because it's a set. Yeah. So Microsoft, for instance, knows very well that unless they see an order by clause in a query, they can return the data in any order that they like, even if it resides in a specific order in a specific index, and they decide to pull the data from that index. Yeah. They don't necessarily have to pull the data from the index based on index key order, for instance. Yeah. At any rate, what we need to understand is a query with an order by clause doesn't really return a relational result. It doesn't even return a table result as far as SQL is concerned, because a table cannot have predefined order at the conceptual level. So the order by kind of takes us outside of a relational theory in a way. Anyway, if a view is supposed to represent a table, from the model's perspective, when you use the term table, it could represent either a base table or a view, yeah, or a table expression for that matter. You realize that the standard language is not supposed to allow us to have an order by clause that defines ordering for the view. A view is not supposed to have order. So if you ever tried introducing an order by clause to your inner query, let's say value descending, you got an error message saying that this is not allowed. And you got the very same thing for all kinds of table expressions, for views, for CTEs, for derived tables, and for inline table valued functions. So it's not like Microsoft had any technical issue with supporting this. They didn't introduce such support because of the roots of this language, because of the underlying standard language and relational theory. Thing is, if you read the error message a bit more closely, you will see that the error message says we're not allowed to use this order by unless we introduce certain language elements that actually rely on the order by clause for purposes other than presentation ordering. So for instance, if you add a top filter, let's say if we said give me top 3, order by value descending, my purpose in using the order by clause is to support the top filter. Yeah, so the ordering here is part of the top filters specification. Now, clearly, if they wanted us to be able to define views or other table expressions based on top queries or offset fetch queries, they had to then make an exception and suddenly allow the order by clause in such exceptional cases. And indeed they do. If we go ahead and create this view, you will see it's valid. The tricky part that many people don't realize is they're thinking now that not only that they will get the data back from the view with the right filter applied, i.e. get the 3 rows with the highest values, people often just assume that they will always get the data back from the view presented, ordered by value descending, not realizing that Microsoft made this exception only to support the top filter, and unless the outer query, unless the outermost query has its own presentation order by clause, we do not have any guarantees in terms of presentation order. Now, it could very well be that for optimization reasons, SQL Server will decide to process the data either pre-ordered from an index to filter the right rows for top, or impose a sort or a top n sort if there are few enough rows. So it could be that the outcome of optimization will give you the data back ordered, not because it's guaranteed, because this was the optimal thing to do under those specific circumstances. So if I go ahead and run this query, notice it appears that I'm getting the data back ordered by, value descending. And many people just think that they can trust this to always be the case, not realizing that in theory, under certain conditions, the optimizer will suddenly choose to not process the data in this order or impose some, additional steps beyond the step that pulled the data pre-ordered from an index or sorted and so on. Yeah, people just don't realize that this is something that they cannot really or are not supposed to trust. And in fact, you're probably familiar with this old attempt to go and introduce a top 100% into the inner query, thinking, hey, now that I have a top, I'm allowed to put an order by clause, and now I'm getting my sorted view. So putting a top 100% in the inner query, people think that now they have a sorted view parallel to Oracle's sorted view. Now, if a vendor says, I'm supporting this feature, here is the documentation describing how to create a sorted view, even if it's something that doesn't originate in the standard or is not backed by relational theory, a vendor always has this option to guarantee something that they wish to guarantee. Yeah, but just be aware that in SQL Server, Microsoft never provided such a guarantee. And as far as they are concerned, if you want to guarantee presentation order, you need an order by clause in the outermost query. So yeah, notice what happens. If this was my outer query, let's pull it aside for a moment. If this was my outer query, now the order by actually serves two different meanings. One, it serves as the top related filtering meaning to define which rows to filter, plus a second meaning that has to do with the presentation ordering guarantee from this query. Yeah. And you know what? This design is a little bit, I would say, confusing, because there are two separate kind of logical steps that rely on this ordering, and people don't always realize it. They suddenly have those expectations that if we use it in the inner query, somehow it gives guarantees also to the outer queries presentation ordering. Theoretically, Microsoft could have used a different design for top, and same goes, by the way, for the standard offset fetch filter, which is designed very similarly in the connection that it has to the order by clause. These tools could have been designed with their own ordering specification for top, like with window functions, not confusing it with presentation ordering. So if I wanted, the 3 rows with the highest values, yeah, I would have written like this. And instead of a presentation order by clause, imagine if I could just say here, order by value descending. This would have been a much better design for us, because we would then have full control. I need this ordering for the filter, and I don't want it confused with presentation ordering. And perhaps I need one order for the filter and a different order for presentation ordering, and definitely no confusions around using it in an inner query and having whatever outer presentation order by that you like. Yeah, but that's kind of wishful thinking. That ship has sailed already, and we just have to, get used to the existing syntax and its guarantees and non-guarantees. So here, as the outermost query, I definitely have a guarantee that the rows will be presented by value descending order. But if I define a view based on a top 100% query with an order by, and my outer query doesn't also have an order by clause, SQL Server's optimizer is smart. It says, you know what? My outer query doesn't care about ordering, so I don't have to provide any presentation ordering assurances. As for the inner query, well, does it really filter anything? Top 100% naturally doesn't filter anything, so it figures, hey, I can optimize the combination out. And when the optimizer gets to optimize the simplified query, clearly there's no ordering element involved anymore. So when you try querying the view, notice you're not getting the data back ordered in any special way. Even if you did, remember, it's not guaranteed. But I'm saying this is so easy to prove by knowing that the optimizer has those more kind of sophisticated contradiction detection capabilities, and just optimize out elements that are not needed, what could result in better optimization, naturally. And once people figured out that this is something the optimizer can do, and by the way, I don't know how many of you worked with the very old versions of SQL Server, but this optimization trick was introduced in SQL Server 2005. So when people attempted to create a sorted view in 2000, this trick wasn't employed by the optimizer, so people thought that they could rely on it to create a sorted view. And this is another reason why it's so dangerous to rely on things based on observed behavior. Maybe now it looks like it's ordered, but who says that it will keep being like this in the future? Yeah. So, once people discover this, they started looking for alternative methods. For instance, using not a top percent, but a top number, but a very large one. Now, top works with a big int as its input type. So we could take the largest possible 8-byte integer. So that's 2 raised to the power of 23 minus 1. This is your largest possible, actually 2 to the power of not 23, but 63, of course. So we have, this is the largest possible big integer that you could have. So, people just use either this number or just a very, very, very large number that is way larger than the results that could ever be. And now, if I go ahead and query the view, notice the optimizer doesn't realize, hey, I can now optimize the combination out. But I would still not consider it as a safe way to guarantee presentation order. I sometimes use this technique for other reasons. When I want to prevent the unnesting of a table expression, sometimes the optimizer will unnest logic in table expressions because it can result in better optimization. But at times, either because you want to prevent certain expressions from being evaluated in certain order, or for some performance reasons where you realize that after the nesting, in some, let's say, unusual cases, you end up with a worse plan than the original one. By using this technique, you can prevent unnesting, but this will only affect optimization considerations that you want to impose. Conceptual behavior, like getting data guaranteed ordered, this will still be something that I will feel very uncomfortable suggesting. Yeah. So yeah, I would not advise this. By the way, there's yet another trick. Those of you who already started working with the offset fetch filter, where we can add at the very end of the query, attached to the order by clause, offset a certain number of rows, and then fetch next, and then a certain number of rows, usually used for purposes like pagination. Here, we are skipping a certain number of rows and then filtering a certain number. This is a feature that was added in SQL Server 2012 and is standard, by the way. So for those of you who haven't used it yet, hopefully this description was sufficient just to understand the meaning. Instead of just saying, I want to filter X number of rows like we do with top, we first indicate how many we want to skip under the offset clause, and then how many we want to filter after we skip that many. So here, skipping 25 rows and then fetching rows 26 through 35. But you realize that if I'll say offset 0 rows and I will not indicate how many rows I want to filter, essentially, effectively, I'm not skipping and not filtering anything. The thing is, when you just skip rows and don't indicate how many to fetch, you're just fetching everything that is left, meaning everything. But also here, the optimizer kind of fall into this trap that it doesn't recognize that there's no real presentation ordering needs here, and we're not really filtering anything, so it could eliminate the combination. No, it kind of falls into this trap. And now if we go ahead and query the view, you will see that we're getting the data back ordered. But again, I'm not showing those techniques or those tricks because I'm recommending to create sorted views like this. I'm just showing you what kind of techniques people are using, and I'm warning you against trusting them. Yeah, don't be fooled or don't be misled by observed behavior. It could keep running like this a million times. Could be that next cumulative update of the product, Microsoft will suddenly change how they optimize and realize, hey, also here, we can eliminate this combination and come up with better optimization. Yeah. So as long as you remember this very simple rule, there's one and only one way to guarantee data will come back ordered, never mind if it's from a view or anywhere else. You need an order by clause in the outermost query, period. It's really as simple as it sounds, okay? But if you're interested in seeing more about what I mentioned earlier, using the stop with a very large number and the fact that I use it as a way to prevent unnesting, check out a series of articles in sqlperformance.com covering fundamentals of table expressions. I'm actually in the middle of the series. So far, it has something like 6 or 7 parts, but there will be more. I go into quite great details, both describing the conceptual treatment and optimization treatment, and I even show how I use these techniques to prevent unnesting and how this can be done both for optimization reasons in some cases and to prevent certain errors in the query. So check those check that series out. You'll find some very interesting things there. All right, so we're moving on to our last workaround, and this is a workaround to limitation in SQL, not just T-SQL. Yeah. So the issue here is this: you have a query where you want to create target columns based on computations, but you also want to use those aliases that you assign elsewhere in the query. Yeah. So for instance, imagine that I wanted to return, let's do return orders that were placed on an end of year day. Okay, only orders that were placed on an end of year day. So I'm thinking, let's do this. Let's take order ID and the year of the order date, which will alias as order year from orders. Now, of course, nothing too special about this query. I just extracted the year and assigned the target column name order year. However, imagine that I now want to go and take this order year alias and go ahead and based on it compute an end of year alias. So let's say using the date from parts function, use this order year that I just computed, adding December 31st as the month and day units and naming the result column end of year. And since I only want to return orders placed on an end of year date, I want to also maybe add a filter where the order date is equal to the end of a year date. And we have two issues in the query though. It seems like this is something that you're supposed to be able to do, but you can already see the two red lines below order year and end of year. And indeed, if I tried running it, it complains about both aliases. What's the story here? Well, the story is this. For one, the reason why we cannot reuse order year, which we just created in the expression to the left, is, remember I talked about the fact that a table is SQL's counterpart to a relational theory, and I said that the table expression, and this is a table expression by the way, returns a table result. And a table has a heading and a body, and what defines the heading of the result table are the expressions in the select list. And being that the heading of a table is a set of columns, there's not supposed to be any specific order. They come into existence at the same point in time, being a set. So the fact that I created an alias called order year in the select doesn't make it available yet to the expression to the right. They're a set. This explains why we cannot reuse the alias in the select. How come we cannot reuse the alias from the select in the where clause? That's a different story. It has to do with the fact that we type the query clauses starting with the select, proceeding to the from, then the where, then the group by, then the having, and then the order by. That's how we type the various query clauses. But the interpretation of the query clauses actually works a bit different. The select piece is actually handled after the having and between and before the order by. So first, the language has to figure out which tables are involved and any table operators like joins. Then do we need to filter anything? Do we need to group? Do we need to filter groups before we get to the select to prepare the heading for the result table? So clearly then, anything that you define within the select, which is here, is not really visible to any steps that are evaluated before the select. That's why you cannot use aliases that you define in the select in places like the where, the group by, the having, and so on. I remember once I gave a lecture in a conference and someone came to me at the end of the lecture and asked me, when is Microsoft going to fix this bug? And clearly this is not a bug. This is part of SQL's design, not something that even Microsoft chose. So how do we fix this? Well, there's a classic solution using table expressions. But then, here we have dependencies. We first need to create order year, then end of year based on order year. So you end up with a CTE based on a CTE based on a CTE, and then an outer query. The solutions tend to become very kind of convoluted. So a much kind of a cleaner, easier, simpler approach is to use, remember the cross-apply and values clause that I used earlier to solve the alternative to greatest and least? We can use it in kind of a similar way, but without unpivoting anything, just using cross-apply along with the values clause to define a table expression that will then have those extra columns. So let's say we do a cross-apply, creating a table expression called A1 with the result column for the year, and within it, a single row based on a values clause. In this case, based on the expression, from here, we'll just move it down over here. And that's something that requires us to gain access to a column from the outer table, which apply supports. If you try to do the same thing, say with a cross join, you would get an error. And now, using a second cross apply, we can go ahead and create something that depends on all the year. So creating a second table expression called A2, and then rely on this computation to create end of year, and of course, name the result column end of year. And we don't necessarily even need to show end of year because we're filtering only rows from an end of year date, and therefore it's enough to show the year itself, and suddenly all red lines disappear. Much more elegant, defining the expressions based on the dependency order. We don't need to repeat logic that is unnecessary, like if you used full-blown table expressions, and it doesn't have any performance implication because of the unnesting of the logic that takes place here. Okay. So yeah, I rely on this technique, so often, and I'm sure that if you haven't used it yet, you will find it extremely useful. So this essentially concludes the topics that I wanted to discuss. Make sure that you download the source code for this session. If you want to be able to reuse these examples, go to tsql.lucien.com. There you will find a section with resources and then downloads and source code for recent conferences. I hope that you really like this kind of material and generally advanced T-SQL topics and query tuning aspects. I would very much love to see you in one of my more extensive five-day classes about advanced T-SQL query tuning that I run quite regularly. Thanks very much for attending. I hope you will enjoy the rest of the conference. Don't forget to fill out your evaluations. And now I will take any questions. We have a few more minutes left for a Q&A part. So shoot your questions, please. Thank you. Take care.